afraid.
Military crawl my way out of here.
Set? All right, everybody, thank you for coming today. Really appreciate it. Hopefully we can be respectful of your time, get you guys in and out of here as quickly as we can, answer some questions. The goal today is to try to be as informative as we can, to try not to be too technical, but we'll answer any questions as we go. We kind of have a timeline involved, but it is our first go around doing this, so certainly if you have specific questions you need answered, ask them. Thank you again for being here. Just a little bit about Schmidt Custom Floors and myself. I'm in my 18th year now doing athletic floor specific. I installed for many years, sanded, wrote a manual on sanding, all the processes, and have the physical knowledge of doing the work. And I take a lot of pride, and I think a lot of our managers here take a lot of pride in having that physical background versus just reading the CAM to you. So that's something that we can add, and what I really appreciate about Cat 5 as well. We're companies that both individually do the work. We don't just read things to you, which I think is what people want to see. I'm in my 5th year with Schmidt Custom Floors. I've been doing it before then. Mr. Tim Schmidt actually bought my company out, and it's been a great relationship. So Schmidt Custom Floors started in 1968, family-owned business by Robert Schmidt, Bob Schmidt, Tim's dad. A couple of people, one truck, family-owned, out of their home. And here we are in 2016, almost 17, 150 employees later, 3 major divisions. I'm the athletic division manager. Tom Zarek will be speaking. He's our commercial division manager. And we have Ryan Guthrie, our residential division manager. Tim, his family, his children, his sons, his wife, his daughter are all physical members working in the field, in the office, being a part of everyday activities. We handle anything from recovering wood today, but we also do carpet, tile, laminate, VCT, linoleum. We have, you guys didn't see this coming in, but the entire upstairs is a carpet, tile, and pre-finished wood flooring showroom. You're certainly welcome to stay after if time isn't pressing. Be glad to show any of you around if you want to see more. But again, I'll turn it over to Steve.
I'm Steve Kukashki. I'm with Cat 5 Restoration. I wanted to thank each and every one of you for coming out today, taking time out of your busy schedules to be with us. It means a lot. I appreciate that. I hope that you find the seminar informative and educational and enjoy yourselves while you're here. Many of you already know, but for those that don't, a little bit about Cat 5 and who we are. Cat 5 Restoration is a full-service restoration company. We have 3 separate divisions. We have a commercial division, which makes up about 85% of what we do. We also have a residential division and also a reconstruction division. We are a privately owned company. We're not a franchise model. So all of our branches, all of our response centers are from Wisconsin all the way down to Florida are owned by the same individual. I think it's important to note that because we're owned by the same individual, that all of our processes are the same, regardless of the location. So how we respond to a water loss or how we respond to a fire loss or a mold loss in Madison, Wisconsin, is the same process in place for Waukesha or for Milwaukee as it is in Chicago and Indiana and all the way down to our Tampa, Florida office. Consistency is the one thing that we really tout above everything else when it comes to our company. We feel that gives us a distinct advantage over our competitors who may be more of a franchise model type business. People love us for many different reasons, but if you were to sit down and talk to those who use us, that word consistency would be the one thing that you would hear over and over again. There's something about knowing what you get each and every time that a restoration company steps out on your loss, knowing that those processes are the same. I could stand and talk all day about who we are and what makes us noticeably different from our competition, but I won't. You're not here for that. But feel free to grab any one of us after the seminar that has the Cat 5 logo. Be happy to talk with you a little bit more about that. Without further ado, I'll give it back to you then. So.
Thanks, Steve.
Yep.
All right, so a little bit of background, which kind of is informative, and you guys walk into a gymnasium. My goal is to give you some tips and things to look for to decipher what are you looking at, and it can be very deceiving from one floor to the next. To give you a background, first of all, we are a dealer for Connor Sports Flooring. Connor Sports Flooring's been around since the late 1800s. Started in Leona, Wisconsin, and now they're mills in Amosau, Michigan. Kind of a neat little history background of the entire association. So they're one of the mills that's associated with the MFMA. So when you go into a gymnasium, MFMA is Maple Flooring Manufacturers Association. Most of you probably know that name. If you actually were to have a loss and the maple got torn out, usually every stamp on the back of every single board will actually say what mill it is, and then it's MFMA lumber. If you bid on a project today, a specification 99+% of the time is going to have one of the MFMA mills in there. What's unique about this? There's only 6 manufacturers that have made all the manufactured wood for basketball courts basically since the basketball was invented. Most of them were around before it was even invented. So if you take Connor, for example, today they produce almost 500 basketball courts a year out of Amosau, Michigan. And uniquely enough, since we're all mostly either live in Wisconsin or from Wisconsin or northern Illinois, all the maple, for the most part, is grown in northern Wisconsin or the UP for all 6 manufacturers. So we talk about systems today. I'm going to show you some different Connor sports floors, but every manufacturer has an equal or an alternative of the very same or similar. So when you ask a Cat 5 to come in and dry it, or you ask us to come in and decipher it, it's relatively easy, having done it as long as we have, for us to decipher those things, but I'm trying to share with you how you can walk in and some very simple things to be able to figure out what you're looking at. You'll see in your handout a couple of one sheet that has 3 columns. And if this was a sales presentation, I was showing you basketball courts, we'd be talking about the different types of performance. I'd be showing you a fixed floor, a floating floor, and a fixed resilient floor, which essentially is a floating floor with some anchors incorporated into it. So what does that mean? How do you dry that? How do you tackle it? And it's very deceiving. And part of the reason you're here is to be able to understand and figure out how do you decipher that. Quick example, we have a project right now that's an anchored floor. Before I get into what an anchored floor is, it is completely soaked, and the only real determining factor walking in is it's black in the butt joints. But it's not humped, it's barely even cupped. But you look at that and you may say, well, I had a loss 2 years ago and that floor was this high off the ground, and it may have had half the moisture that this particular floor has. And that's why it's important to understand when you walk in. So just to give you an idea, an anchored floor is basically mechanically fastened to the substrate. So this is an example of what is very synonymous with old floors. It's called a clip and channel. There's a steel channel running perpendicular to the maple, and there's a bulldog clip essentially holding the underside of the tongue of the maple right to the concrete. There's no resilience. It's not sold for that. It was made as one of the originators of basketball courts. Deceivingly, again, it's also inch maple, which they don't even make anymore. So the more structurally intact that a board is, so width and thickness, that is synonymous with the same type. Say it's an inch wide, inch thick. It's a lot more structurally intact than say 4 inch wide, inch thick. So my point is, when you walk in on a floor like this, you have quite possibly the strongest pull out strength that you can get out of a floor, coupled with maple that doesn't show signs of moisture. So when I walk into this floor, how do you determine? For me, it's a moisture meter. And I don't know if you guys carry moisture meters, and we're not selling you just to take moisture meters around. But you can walk in, there's a couple of easy things, and you can see this in your little pamphlet there. The first thing is, I stomp on the floor. You can already hear, even though this is an echoey environment, that this is hollow, right? That immediately takes out the idea of a completely anchored floor, because there's some kind of air underneath here allowing you to hear that sound. Similarly, when we've all done this, when you've tried to find a 2x4 on the wall, just by knocking on the wall, and you can hear it when it hits the 2x4, that you hit something hard. A maple floor that's anchored completely, either with a steel clip and channel to the floor, or the other kind, which is a nail strip. Either way, it's completely adhered to the concrete. So clip and channel, nail, or even adhered with adhesive. The first thing is, it's super hard, and you just know it. It's not even subjective. You're going to feel it. It's really hard. The second thing that you'll look for on there is a lot of the old gym floors will have wood base. And wood base is very synonymous with the old clip and channel or a nail down anchored substrate, anchored to the substrate type floor. A third thing would be, you've seen the old gymnastics inserts that are about this big around. Those gymnastics inserts are installed and routed flush right into the maple with no ability for that floor to laterally move in any direction, which means you basically created a vertical obstruction in a floor and connected it to the concrete. That's a no-no on a floating floor or an anchored resilient floor, for example. So if you see that, you walk in, you see wood base, you see an anchored insert from gymnastics, and it's very hard, you immediately know that you're looking at some kind of an anchored floor, which will give you a deceiving difference from the floors we're going to show you as we proceed going forward. I don't know if I have to get into too much detail. Up here, you guys can look later. There's the different maple, and 99+%, even though the MFMA allows beech and birch as an acceptable species on a gym floor, almost all gyms you walk into are going to be maple. So just something to note. It's nice to know the different sizes that you're looking at, because the less width you're dealing with, as far as face width when you're looking at it, the less you will see as far as how moisture is affecting it. So as an example, what you're standing on is 2¼ inch wide maple. If I have 1.5 inch wide maple, the effects visually of this are going to be a lot less than they are with this, just because it's structurally more intact, right? So that's kind of the idea of that. A couple other floors you may see would be like a parquet floor, and you'll see those either in an oak or a maple. They can be either direction. Those typically, and you can tell as well, they're very hard. Otherwise, there's an old floor called ironbound. And ironbound is basically 1-foot strips of maple that you can't see, but every butt joint has a groove, and there's a piece of steel that's holding that groove and the groove of the next piece to the floor, and it's glued and adhered to the concrete. That's an anchored floor as well. When those floors buckle, you'll actually see them come up this high, and it'll make you think, well, how can that possibly not have a subfloor under it? Well, it doesn't, because that steel channel essentially is holding it together like a web. And you know, it can get kind of difficult to 100% figure out what you're looking at, but the key is if it's anchored, it's obvious because it's hard. I think John's going to come up in a little bit and speak specifically on an anchored floor and how we tackle it, but I just want to give a quick example of the importance of your guys' job as you're called to a job site and how moisture can migrate. It's really not recognized or articulated greatly how fast moisture can infiltrate and laterally spread. And if we're really trying to salvage, time is of the essence. That doesn't mean Cat 5 and Schmidt Custom Floors are looking to get out there and get the contract and get things going. What it does mean is we have to do something, even if it's asking you guys to tell the facility manager what to do. And here's my example. We work with UW Stevens Point in the Quant Gym, which is the main basketball court. You walk in that court, you stomp your feet, it's hard. The base, the gymnastics inserts, all synonymous with an anchored floor. On Thursday, a pipe burst in the wall. They figured they picked up about 15 gallons of water. Why? Because their machine holds 15 gallons of water, and they only had to pick it up with one pass, you know, going around and picking it up. They waited until Tuesday of the following week to call because they hadn't seen any visual damage yet. And by that point, and you're talking about this floor, which shows the least amount of initial problem, what happens is the moisture gets into that maple, it expands super tight, and it can't get vertically out because the finish on top almost now is pressed so tight it's like putting saran wrap over the maple. So what can it do? It'll only go lateral, right? So my point is, if you take this space of this gymnasium, it probably affected about this big a spot, but because there wasn't a discussion or something done, by Tuesday, and I drove there immediately when I got the call, it had now spread into about 4,000 square feet, and this was the year they won the Division III National NCAA Championship. And the moisture was infiltrating the main basketball court to the point where if they waited another day, it would have been cupped so bad in the main court that they couldn't physically play games. So I made the executive decision standing there, knowing that it's this floor, and this is really the only floor you can do this with. So while it sucks for, the performance value, it doesn't provide any structural resilience for your body. It's awesome from pull-out strength and its ability to be able to withstand huge amounts of moisture and movement. I basically said, similarly to a forest fire, we need to cut a relief cut in this floor. So that day, we cut a 50-foot pass perpendicular right down 1 foot off of the main border to basically create a 1/8 inch gap between the main court and where the moisture was, so that moisture didn't jump over into the main court. If you were to do that with any other floor, say a floating floor, we're not talking about this now, but if I cut this right here, it's resilient. It'll literally bounce from one to the next, and it'll be unsafe from that transition. Where this is held so tight that we can cut it, not only did I know it wouldn't lift, but I knew that it would allow us to cut it and stay and be safe. And that cut's still there today. We actually epoxied it, resanded the area after Cat 5 dried it, and fixed it. So it just shows the importance of knowing what you're looking at right away, and either calling, and again, we're going to be kind of technical today, but just calling. Call me if it's a gym floor, or another gym floor guy that you're familiar with, just to get an opinion right away. There may be some things we could suggest right away so that you minimize your loss drastically. And just this 4 days at Stephen's Point went from a couple thousand to tens of thousands. So if you want to articulate some drying methods on anchored floors, this is John from Cat 5.
Yes.
And Mark from Cat 5.
Hi guys, John Greasy at Cat 5.
Mark Otto, Cat 5.
So basically anchored floor systems, which Jason just told you about. The only way to dry an anchored floor system, if you look at this packet I gave you guys, there is a picture of a tented system. The water basically in an anchored floor system goes in one way and has to come out one way. So the only way to get it out, obviously, is to diffuse it out. And to do that, you need to remove the finish layer. And once the finish layer has been removed, you then put an enclosure or a tent system over it. The most important thing, however, is not to just blow unwanted, unconditioned air into that tent. The air going in needs to be conditioned, needs to be dehumidified, and there needs to be a moderate amount of heat, because the heat will help with the evaporation. And the dehumidification will take care of the vapor pressure. So a floor like this, for instance, Stevens Point, good example, it was only a third of the floor, I believe, that got affected. So if you do have an anchored system, and in most of the floor gets affected, let's say 50% or so, you're going to lose access to that floor for the next 4 to 6 weeks, depending on how long it takes to dry it out. So going into that, it depends on what kind of activities you guys have planned or the schools have planned. That way it doesn't disrupt anything. So sometimes you try to dry it first. If it doesn't dry, then you move on to the next thing. Next phase would be to remove that floor system.
And you'll see a lot of times that people try the floor mats. I'm sure you guys have seen drying mats. Those work well to get rid of the freestanding water.
Yes.
Look, the problem with the drying mats, if you just put a mat on top of a finished floor, that finish is meant to not let water go in, which also means it's meant to not let water come back through it. And a drying mat's not going to suck water through a finished surface. It'll get rid of the freestanding water that may be inside of a crack in a seam or something like that, but it's not going to typically dry that whole floor out. So if you want to put a mat down for a day or two to try to get some of the freestanding water out, it'll be effective to that point. But after that, the only real way to try to dry those floors is, like John said, remove that surface, tent it, and get the vapor pressure correctly so that moisture comes through the floor and dries it properly.
And
You're talking about an anchored floor only?
Anchored floors,
yes, anchored only.
yes. And the thing with anchored floors, I always tell clients, customers, school superintendents when I go into a school, I always tell them, hey, there's a 50% chance, 50-50 we're going to have this drive for you. Going into it, I don't want, there's guys out there, they say they can dry the world. Either they're very confident or very ignorant. So yes, in-place drying is the way to go, but educate the customers. There is a 50-50 chance this may not dry, it may not return. But absolutely, go forward, try to dry it first.
What we'll typically do is we'll give it a 1-week try.
Yes.
So we'll tent it, we'll start our drying process, we'll do readings daily, and after 1 week, if we're not seeing a vast improvement, we can tell you right then and there the floor's not going to dry. Why waste money for 3 or 4 weeks on drying equipment when it's going to have to get torn out anyways? So no matter who you have on a job site, if you have a contractor, restoration company out there trying to dry an anchor floor, check those readings after a week, see if they went and improved to a drastic point where you're confident that you're actually going to be paying for something that's going to work, and not 2 or 3 weeks later they tell you, no, it's not working, we're going to have to pull it out. and get charged an extra couple weeks of rental fees on equipment.
Yeah, I mean, and actually have them give you something on the last page, a moisture reading page.
Yeah.
You know, everybody's gonna have different moisture reading pages, but these pages quantify the readings they were taking. And you don't need to go take readings on a gym floor every day. It's a dense material. So essentially, twice a week, you need to get out there, the technicians need to take the readings. But if they're not submitting daily updates or when they get their readings, it doesn't let you guys know where the progression is going from. And next thing you know, you got 3-4 weeks into a job, you guys are getting hit for a $40,000 bill. Well, you may want to check that weekly to make sure it's going in the right direction.
And one of the things you'll see in that reading, you'll see where he has it on their top, middle, and bottom. When they're taking those readings, you want to make sure they're using a hammer probe and probing not just the first quarter inch and not just the bottom of the maple, but all the way to the subfloor. You want readings that are showing all the way through the layers, that all the layers are drying, and not just the surface. The surface is going to dry faster, obviously. So you want to make sure that they're giving you readings that show the whole floor system, not just the top of the floor system.
And then one more thing, before you dry anything, we can talk about all the floor systems today, but this applies. What was the source of that water? If your school or the school is near a river and the river overflowed, it's flood water, river water. Floor's got to go. It's category 3. If a sewer pipe broke in the school and infiltrated that floor, it's got to go. In time has a lot to do with it. A lot of floors that I've seen, water gets on the floor, the custodians go out, they extract it, they mop it, put a couple box fans up, they're good to go. A week later, they start noticing cupping or bulging or heaving. At that point, the floor is already starting to delaminate, so it's time to act quickly. But if you wait more than 2 weeks on a floor system that's been wet, it's kind of went from a clean water system into a category 3 because of time has created possible microbial issues. That's just, and the wood could start to disintegrate and lose its structural integrity. So that's pretty much it. So the quicker you act, the better it is. So.
Real quick as an example, so at Stephen's point, when they set the tent up, what I really appreciated about the resolve not only was articulating really to my customer, which is why I had them come in, because I felt confident that they would articulate to my customer the appropriate resolve. We work together, which doesn't seem to happen much, where they talk about the humidity extraction mat. As contractors, you're taking a mat and essentially asking it to pull moisture through saran wrap. If you were to articulate this finish that's on this floor and it got wet right here, I put the mat down to pull moisture through finish. You have to remove that finish. So at Stephen's point, we removed the finish.
Of the affected area.
Of the affected area. And they built a tent. Within a week, it was drastically coming down. The school said it's off the main court. We can accommodate the schedule because it's drastically less expensive than removing going forward. But along that line, and examples I think paint a good picture. We had a project mitigation company, not to be known, but not Cat 5, at UW Whitewater. It was an anchored floor. They had a humidity extraction mat down for a month. Had me come out to sand the floor. They used a laser moisture meter. The importance of having that moisture meter equilibrium throughout through a pin probe is so that it's the same all the way through. If it's not the same all the way through, and we'll articulate this maybe a little more later, and you sand a wet floor and then it dries later, it will look brown. It's not subjective, right? So in this particular case, this example, I went out there, he had readings of equilibrium, which is about 7-8%. And to give you an idea, in the state of Wisconsin, 6% when it's dry and 11% in the humid months is about the standard range of percent moisture content of maple floors in any gymnasium or any floor in the residential that you'll go in. When you reach subfloor, it's very common though to have that 3 to 4% higher than the actual maple is. So note this, if you're at 11% and you go down into the subfloor, it's 13%. That's really kind of normal. Yes. But going back to this example, so I go in, I put my own pin probe down, it's 35% moisture. The humidity extraction mat literally did absolutely nothing. So the only method now is to remove the finish from that area and either allow it over time to dry or put another tent system over the top. The school, because it's an aerobics floor and very minimally used, decided to wait. That wait is about 4 months. It's just a matter of having those conversations. And those conversations don't cost you money. But it could cost you money not having them. And that's really what we're suggesting. in that particular case. So,
Interesting fact, you said it was about 30%, the readings.
yeah.
But what's interesting is the FSP, fiber saturation point. So most of the fiber saturation points are 25 to 30%. So once wood gets to 30%, all that extra water has nowhere to go. That's your free water. Right. So they did remove that free water, the dumb water we like to call it. But they just couldn't get that water out of the fibers of the cells with rescue mats. You bring down the vacuum of space, it's not going to work. Essentially at that point, you need dehumidification and heat. So, good point.
And then a couple things on the systems, the anchored systems. If there's a felt pad underneath there instead of a foam,
Yeah.
you're not going to dry it. You're not going to be able to pull that moisture out of the felt to the point where you're going to be able to dry that floor system. So there's certain things that even though you may think you can sand it and dry it, there's a couple issues like felt where it's automatically going to tell us we're not going to waste your money and try to dry something we know will not dry. Just like felt underneath carpet. You know the felt pad's never going to dry. Same thing underneath the floor.
And great point. So that is another thing that I didn't allude to as well. When you go in, one of your first things to look for is just open up a volleyball cover plate. And you'll see if that cover plate's connected to the sleeve and if it's small. If it's really small, it's more than likely an anchored floor on top of it, because a floating floor typically will have, even an anchored floating floor, will have a large cover plate hovering on its own accord, not connected to the sleeve. So when that floor expands and contracts, you may actually find the sleeve for volleyball that the sanction goes in is real close to one side of that hole, and that's just because it's made to accommodate movement. But to reconcile what he just mentioned with the felt pad or the fiber, how do you know that? Well, you can't just come in and look at the maple, it's got a pad clearly. If you open up that cover plate, you can see it almost immediately. And if it's maybe one thing, I think, if it's 5 gallons of water, but there's no real specific on cutoff. But if it's saturated, I think what he's saying, you're not going to dry out that pad. But this leads into another just quick example. UW Whitewater, again, main game floor, was installed on the second story. That specific gym floor that we installed was called S channel. It has a pad underneath, right? And it falls in line with this example. They called me, it was right after Thanksgiving, and he said, we can't get the bleachers out, your floor is cupping. And cupping is not subjective, it's wet, right? And it's also on the second story, so I know it's not slab related, so there's either HVAC unit or something spilled. And I asked the guy on the phone, I said, is it cupping? And he said, no, I don't think so. So, not even 150 feet away, as I walked into the room, I could see it cupping. Clearly it was wet. So he walked over and we looked at it, and I said, something spilled here. And the girls' basketball team was starting, and there was a team manager that had a cart with a yellow Igloo water cooler on top, with a strap over the top like the old TV trays that would roll. And we just went and asked, do you know if anything spilled here? And she said 2 weeks ago, she was rolling that very cart with an estimated 2 gallons of water in it, hit an extension cord, and it flipped over and poured water out. But they cleaned it up right away. Yeah. And it didn't present itself till 2 weeks later, and the bleachers wouldn't pull out. That example did not saturate the actual pad, and we were able to repair a section because they couldn't get the bleachers out. It was a more than just a mitigation trying to dry it, because they had to physically get bleachers out, so we had to do a repair. But as Mark and John alluded to, if it was 50 gallons of water and that pad's soaked, there's no other method to do anyway. So again, just show us how fast it can migrate without really showing or presenting itself. So I'll get into floating here, if that's okay.
You guys have any more questions on anchored floors, or what to look for, or what questions to ask contractors when you go into a gymnasium that's been flooded?
As well, profiles are very low in anchored floors. So if you just simply open the cover plate and it's like 1.5 inches thick, it won't be any of the other floors. So that's another method to look for. If it's 1.5 inches, it is not a floating or an anchored resilient floor, which we'll explain as well. That can eliminate really everything else right away. It's just things to consider there. But did you have any questions regarding anchored? Didn't sound like? Okay. All right, so the next step, industry basically got to a point where shin splints, body issues, hip replacements, no deflection of these floors. How can we bring some performance aspect to the end user? this is ridiculous. These floors are fast, they play really well, but they perform terribly on our bodies, right? So industry came up with many different types of what's called a floating floor. And that floating floor essentially brought the performance value, like I said. It created deflection, its ability to take our body and reduce the impact versus jumping on concrete as it comes back into our body. There's some different variations of that, but the basic premise of a floating floor is if Superman walked into the building, there's zero obstructions other than wall base sitting over it. I could literally pull the floor out at one piece and remove it. And why is that? The cover plates are not connected to the sleeves. The wall base is glued onto the wall. There are no gymnastics inserts that don't allow lateral movement. Rare occasion where there's an embedded sleeper into concrete, where it's a very hard system, you may find this, but there's a reconcilable method for that as well. What's common with these? Typically there's some kind of a resilient pad in a plywood or a maple system. Almost all of them made, though, have the ability, if you could look under it, and the floor was actually flat across the span, you would be able to see daylight on the other side. These floors you'll find, roughly 30-year-old floors or newer. It's the predominant floor today. So if you go in a relatively newer school, what can you look for right away? Well, all 6 manufacturers use black vented cold base. So if you look on the wall there, that kind of immediately tells you that it's, unless they have the base replaced recently, which is relatively rare in itself, it shouldn't be an anchored floor because this is the base that would primarily go over the floating or an anchored resilient floor. What's the purpose of that? You're supposed to have 1.5 to 2 inch obstruction away from all walls. So if I install this floor, I'm 1.5 inches away from this wall. This base, which is vented cold base, is literally glued to the wall and not the floor, so that I can allow movement in that floor. The bleachers, and that's not actually on the sheet I just thought of, the bleachers are not anchored to the floor. You will never see bleachers anchored to a floating floor. One exception. In 18 years, Kettle Moraine High School had the bleachers anchored to both sides of their Division I field house. If anyone's been in Kettle Moraine High School, we resanded the floor 2 years ago. That floor estimated to grow in upwards of 6 inches in expansion with testing that we had done because of releasing the pressure. And that movement was a lot inherent, but it moved so much it hit the wall in certain areas and we had to cut it back, and it wasn't even moisture related. It was just humidity because of the obstruction. So just something to note. You just look behind the bleachers are attached to the wall. It probably took out the anchored floor because most anchored floors would have the bleachers, unless they were new bleachers put in. But most of them were anchored right to the floor because we don't have that issue with movement with the anchored floor. So how do you determine? And here's another example. This would be like a sleeper. Sleeper with pad. Sleeper is like a 2x4 or a structural ply product that the manufacturer makes. It's a certain amount on center. And you walk into a gym, and how do I know? One of the first telltale signs if it's a real old sleeper system or floating floor is it's super hollow, hard, and you just obviously know and you can ask the facility manager or the athletic director if you happen to talk to him, do you have dead spots? And if he says it has dead spots, it like immediately tells you that it's probably a sleeper system and it's old. And the concrete over time has moved and it's not sitting on the concrete perfectly. And you have areas where it's not touching, and it's dead, and it's hollow, and it's hard, and it's very inconsistent, in other words. So one of the things we like to use, and I'm showing it on an anchored floor, but it's something that you may want to have with you because it's small, and it really helps bring value to what you're looking for. If you haven't seen, Mr. Scott Taylor's here. He's an NWFA, National Wood Flooring Association inspector. He turned me on to these, so I have to give him a shout out real quick. He turned me onto these several years ago. This is a 1/2 inch spherical or round magnet. They are very strong. So just to show you an idea, and the purpose behind this, my daughter hurt her fingers playing with it once. But they're very strong. And what's the purpose of this? For a very small amount of money, so these were like $50 total, I can bring this across the board joint and find where the nail is. right? And from the top, I can find exactly where the nail is. Why is this useful? Not necessarily going to weed out exactly what subfloor you're looking at from a floating floor, but it will weed out a sleeper floor. Why is that? Because I'm not going to have nails in the middle. I'm going to have nails on every sleeper. And then I go the next row over, and they're on every sleeper, and then on over. So you'll have rows perpendicular to the maple, and you look like a genius because you basically, without seeing the subfloor at all, can decipher if you have a sleeper floor at all or not, right off the bat, just by the use of magnets. So something very easy.
So those same magnets, I apologize for interjecting, those same magnets will also assist you with an anchored floor, with the channel and clip. Will
Yes.
give you the same indication of a consistent nailing pattern. It helps on basically any type of flooring system you have. Identify the key component, which is how is that maple anchored to the substrate.
Exactly. So at Stevens Point, we said was the clipping channel. I have my magnets, and I found rows because it would find the metal every so often. And in the next board, I would do it again, and you would have these rows. And because it was so hard, had wood-based, had gymnastics inserts, I knew immediately it was clipping channel, just simply because of those variables using the magnet. And we have pictures of that from when we first went up there and then shared them with Cat 5. There's a lot of different types of floating floors that are out there. For example, you have the sleeper with pad, you have the pad and plywood, you have more of a performance steel encased sleeper, but you have to be a little bit careful as they come in. This is a performance floor made under duress of high humidity, will not buckle on you. But you can automatically see what potentially could be a problem with this. It's sitting right on the substrate. So while this is made for the structural integrity, if it literally got wet on the bottom, you're asking him to dry plywood from the bottom. So that's something, to consider. That's a rarity to be able to come across something like that. This particular floor, there's a couple of competitor manufacturers and dealers around the country. It's probably the most prone to movement floor made, not even probably. It is for sure the most prone to movement floor. It's a dimensional 1x6, very prone to humidity and changes in environment. The downfall to this as a floating floor is its 1x6 is sitting on closed cell foam. So if it gets wet and you look in the insert and you can see 1x6s at all, that's what you're dealing with. Now you know that you have something bigger on your hands than just having John and Cat 5 come out and dry it.
Wouldn't be the indication that application is that if you just see solid wood, that you know that it's not like any other system, because almost all
Yeah.
the products are used with an engineered system.
Great point. So you open up that insert and it's solid right to the ground. There's no gap underneath. You've pretty much shown that you have that system. So if you want to talk about the drying aspects of a floating floor.
Absolutely. So floating floors. Essentially a floating floor, in layman's terms, it's a floor that we can get airflow underneath. The ideal floor to dry is to get airflow underneath the floor. With that, you have a very high success rate of returning the floor to normal equilibrium. So essentially, you're going to have a positive and a negative system. You're going to set up, and I do have an illustration on one of these. If you go to, it's a floating floor system drying, you'll see negative plenum. What you guys are seeing in that picture is a box plenum system up against the wall. We've removed some of the boards to get enough airflow underneath that floor. We've inserted 4 HEPA air scrubbers at 1200 CFM apiece. So the goal, the intent, is with anything, you can't dry anything unless air movement's blown across the surface, like a wall, like a floor, a ceiling. So with this system, this is creating an enormous vacuum on that plenum box. So that air it's pulling it from under the floor back into these air scrubbers and it's exhausting it out to the gym. On the other side of the gym, we have something called a positive plenum, which is on the next page. Now the positive plenum, what you're going to have over there, it's going to mirror the same length as your negative plenum, and it's based on affected area. If the area is affected, 60 feet across, your plenum's got to match 60 feet across. If it's 30 feet across, then your plenums are a little smaller, 30 feet. It's got to basically pull that air directionally underneath the floor and it just keeps whipping it around. So with a positive plenum system, you have to make sure that you're introducing dehumidified air into that system. and good airflow. So sometimes with these plenums, you can't really see it here, we'll actually put air movers in there, snout nose, we'll aim them upside down. So it's basically pulling that dehumidifier, which we have right in the middle, it's a desiccant dehumidifier, a small 600 CFM unit. That will give us the low vapor pressure, the heat needed to get underneath that floor. And those air scrubbers on the other side are just gonna keep whipping it through. So, and then you take your readings. You take your readings, you know, twice a week. You find your unaffected area, and you have a goal, whether it's 6%, 10%, or 11%. And that is your target goal. So
two things on that John talked about. One is the desiccant and one is air scrubbers. You'll see some companies try to dry gym floors with LGRs, standard LGR. You're not going to get the proper vapor pressure to properly and correctly dry gym floor. Your best option is to use a desiccant, if at all possible.
if at all possible.
On the other side with the air scrubbers, sometimes you'll see people using an air mover, an axial, pulling that airflow negative. The reason why we use air scrubbers, after 20, 30, 40 years, we don't know what's underneath that floor system.
Exactly.
Is there mold? Is there something under there? We'd rather be safe and use an air scrubber, so it's purifying that air as it's blowing into the gymnasium, and it's not just blowing dirty, nasty air into a gymnasium.
So you got occupied schools.
Yes, it's an occupied space.
Absolutely. So it's a simple system to dry. I mean, it sounds simple. We make it sound easy, but there's key components to doing it. You basically want to have people that know what kind of conditions are going on that floor. It's just not hooking up a dehumidifier, plugging it in. You actually got to know what that dehumidifier, what's the RH, what's the temperature. If they're not paying attention to those things, you're not blowing any air. The air's moving, but it's not the right air.
It's not drying.
You know, you definitely want to make sure you have the lowest vapor pressure, which means lowest RH, highest temperature.
And you should be able to ask your contractor to show you what the pressures that's getting pulled. There are tools out there that they put a meter on there to show what negative or positive pressure is going underneath that floor system. So they should be able to tell you what's going on with that floor and how much flow is going through.
And that's this system right here. Now these guys, you've probably seen some of these, a lot of abatement companies use these for asbestos, mold. These are to tell if the containments they're doing the remediation at under negative pressure. So essentially what I've done over the years, same thing. If I build a plenum and I fire up the air scrubbers on this side and I come to this side, I put the hose in there. If this starts going negative, that tells me those machines are drawing that air efficiently across that floor. So a lot of companies, they just set up air scrubbers, a push and pull method. But are they really getting a draw of air across that floor? Because if they're not, they're spending a lot of time and a lot of money, and they're not getting anywhere essentially. So they have to know the pressure, the draw, essentially.
Any questions about a floating floor?
How much consideration do school systems give to when they install this to the eventual water that they're going to have to get out?
Yeah, I was gonna respectfully use the term little to none, but none is really more of the answer. In the high 99+%. You know, cost, budgets, providing performance value.
That's
we're
why
trying.
there's always pressure on Cat 5 and the insurance companies because they never expected that to happen.
Yeah, and on top of that, it's very hard as a dealer in an area like Wisconsin where we hope the end user can control, per the specifications, per the MFMA background, a 35 to 50% constant relative humidity. In 18 years, I have yet to see a customer do that one time. And that's considering Marquette University, UW-Madison, Final Four game floors, Division I high schools, most of the colleges in the state that we've worked with over time, recos we work in. We are working in adverse conditions, let alone water. And we're talking about water and mitigation there. Almost never. And you try to talk about the structural integrity side of things, there's a lot of value in certain instances, and you can sell that side of it. Not necessarily as a selling technique, but just as this is the intent of the end user, this is the level of play, this is the performance that they want to have, and along with that comes the structural integrity, you know, and then other variables if it's a retrofit or after the fact type system. But today, a new specified gym architect will give the most generic, cheapest system you could possibly get. And short of talking to the end user, and the general contractor subjectively could get mad at you just for having that conversation, you're not going to usually push anything that has structural side of it to an end user. So I would say to this day, most of the colleges and high schools that we deal with still go with a floating floor that has zero structural integrity in comparison to any of the floors that we've talked about, you know, at the beginning. So, did I answer the question?
So one thing to touch base on the drawing side of it, if you look at one of the pages under readings, when you're doing readings on your floor, you want to make sure for when it's marked off, and you have a pattern of where you're taking your readings at. The other thing you'll see as you're going through and walking a gym floor and you're looking for readings that the contractor's doing, make sure there's more than one pin mark in that area. If they're taking readings in that same exact hole every single time, it's going to give a false positive. Because the minute you put a probe in and you make holes in there and you pull those out, evaporation is going to happen faster because you now have a hole. So they should be taking readings in a new spot of the floor every single time to get a true reading on if that floor is drying or not. So look for multiple pinholes in the same area, not just one set of pinholes.
That's a good point. And I've seen some contractors, restoration guys, they'll put duct tape over the holes. Even duct tape, I mean, who's verifying that that's a vapor, you know, it's not reliant. So essentially he's correct. If you're not noticing multiple holes, but too many holes is, a lot of the flooring guys don't like that because they see all the holes, but that's how we determine if the floor is truly dry. But another thing, if you're taking a reading here at spot 1, spot 2, spot 3, you can't just take one reading because like anything, if I move over 6 inches, it can be 20% here, that's subfloor, not the maple, and then go up to 40%. So I like to take an average, 3 readings per spot, and I average those readings out over the course of 2-3 weeks, and that tells me where it's drying.
And these meters too, I don't know if it was stated or not, but it's not giving you equilibrium. It's really important to note the actual pin where it's touching in its depth is what it's reading. So that's why it's important to have that probe as it goes down.
And these tips you see right here, these pins are insulated. So as you go down, it's only reading at what the depth's doing. So if I go down 1 inch, quarter inch, half inch, inch and a half, they're insulated coating, so it's giving me a true reading at the depth that I go into the floor with. So that's pretty much, and then we record those readings. You have to record them.
Any other questions about a floating floor?
I will say there was another floating floor that, it's not something that we install, but a competitor of ours installs a floating floor, which basically consists of a closed cell foam and 2 layers of half-inch plywood on top of it. So outside of the normal realm of floating floors is that you can move air underneath them. That's one of the biggest drawing points of that. There are a couple variations that we do not support, knowing the negative side of it. But there are some floating systems out there which have no airflow and are just 2 layers of plywood resting on top of a closed cell foam. So you're getting that resiliency of a closed cell foam that you're getting a performance value, but there's no airflow. And in those situations, you basically take that back to an anchored system now, where you have to go top, and even at that point, you're going to get nothing because it doesn't have the structural integrity of the anchor floor. So a much smaller amount of moisture can cause much larger effects to that floor because it doesn't have the structural integrity that the anchor floor system has.
Good point.
One other thing you may see on some of the floors too is a vapor barrier. You may see plastic, you may see a felt. That may have a variance on whether that floor is going to dry or not also. If that moisture got underneath that vapor barrier, it may make it a little more difficult to dry that floor out.
Yeah, I've seen some floors, literally right underneath the maple, some of the older floor systems, floating floors, you open up the volleyball pool cover, you're looking at the 3/4 inch maple, and what you notice right below the maple, above the plywood, is a tar paper or felt paper. And that right there tells me that it's going to have an issue. That there's chances it may not dry properly, even though it's a floating floor. So those are things you got to look at. Are there blockages between the maple and the wood subfloor? So.
And alluding, as Marcus alluded to and poignantly pointed out, wood is hygroscopic. It's not subjective. If it gets moist, it's going to expand towards its mass. So almost all these gym floors, when they're installed, and this is technical, but there's a reason why I'm telling you, are usually plumb bobbed from the middle of the court and installed tongue side one direction. There's a slip tongue or a fake tongue put in the groove side and then installed the other direction. It may be a little off center, but that's the basic premise. So in a floating floor, as you said, if it gets moist and wet and expands, it's going to expand. If you look at the maple running this direction here, it's going to expand this way. You can actually go into a gym that has 1/3 the water as an anchored floor, and it's this high off the ground. And you can put your hand on the sides of the butt joints the whole way because the floor didn't expand this way. It expanded this way. Hit the wall, and because there's no structural integrity at all, it lifts on you. Humidity also is a funny thing. We look at it in the present. So if you put it in perspective, gym floor, we install it in August, it's humid. Late August, it's even more humid. September, mid-September, this year was still humid. All of a sudden, it's the first week of October and the floor humped. But it's not humid. Why is it doing it now? Because the floor is finished, that infiltration of humidity over time eventually gets to a point where it's affected it in its entirety, not in the immediate, right? It'll cause it to expand and contract, but most of the problems we have, just environmental, not water itself, are at the tail end. Why am I telling you this? You won't even notice that in a clip-in channel, but without water at all, a floating floor will hit the wall and hump this far off the floor just because it wanted to that day. And the last 15 years, it didn't at all. Homestead High School is 30,000 square feet. 12 years after it was installed, the floor had moved so much that the 8-inch cover plates weren't big enough to accommodate the pole to go into the sleeve, just because it decided to move. It wasn't wet. So my point in the deceiving nature of an anchored floor versus a floating is super different. You know, I don't know if that's the right terminology, but you walk into a floating situation, you're going to see a much more egregious end result than you will in an anchored. So you have to be careful in knowing the difference. A little bit goes a long way, both times, but you just don't see those features in an anchored floor.
Speaking of humidity, you know, two summers ago was a very humid year, and we were getting phone calls probably 2-3 times a month to come look at gym floors that were either having cupping or moisture on the top, and they couldn't figure out where the leak was coming from. And every single time we went out, the problem was no leak at all. What was happening is that the teachers were opening up the gym doors all summer long to get airflow because it was a hot, humid, that humid air is coming in, and then it's coming into a cold environment, which is causing condensation, and that condensation was causing the floors to cup and buckle. So just be aware when you're walking through and you can't figure out if there was a pipe break or there was no water leak.
Yeah.
Sometimes it's simply just humidity that's causing condensation.
High dew point temperatures.
A real quick thing when you guys go into a claim, this is actually something I didn't put in the presentation at the beginning, but I just thought of it and I apologize. Just the tape measure, I'm sure you have a tape measure with you anyway. Most of the maple you walk into on a gym floor is 2 1/4 face width. Most of it. If you actually put a tape measure down on the 7-foot mark, so that you basically burn the first foot, we're looking to try to get a 6-foot measurement. So basically, what am I talking about? If maple is milled at 7-8% moisture content, delivered to the job site, I should be able to measure 6 feet and get exactly 32 boards, right? So you walk into a claim, it may be the start of something big, it could be a clip-in channel, you don't really know yet, short of a pin meter. You can put down your tape measure and just measure a place not even close to the problem and see what you're getting. Is it an 1/8 inch expanded beyond 6 feet? Is an 1/8 inch contracted every 6 feet? And give you sort of, a starter number. Now go over to your affected area and put this down, and if you're seeing like a 3/4 of an inch, 6-foot measurement difference than where you were, you know that you're at the start of something that's big time. So just kind of an easy measurement. A tape measure, a 6-foot measure on 2 1/4 face width should be 32 boards if it's the way it was milled. So just an easy one to remember. Anything else with you guys or with yourselves for floating? Okay. The next one is basically a combination of the two. It's the same essential methods that you'll see with a floating floor. So we're kind of being redundant in its drying properties and what we're going to do with it. But it is important to note because, insurance and what is going to be allocated if you do have a repair is now going to change that end result. On the same token, similarly to an anchored floor for its structural integrity, you are adding structural integrity either with a pin that's holding that subfloor down or with an actual partial or full-length channel that's held down like 16-gauge steel and either powder actuated or a Tapcon that's screwed, literally holding it down. The reason why these are sold are not only the structural integrity side, but also the performance. While these are super hard and not great on your body, the ball bounce is pretty good everywhere. It's bad on your body. while these are great on your body, the ball is relatively inconsistent from one floor to the next. And there's a whole lot of common sense behind that. You're not going to get a perfectly flat subfloor. So when these floors go across it, the ball's going to bounce a little different. So that's why the anchored floor that has the resilience came into play, is to be able to have a surface that provides kind of both. You have the structural integrity side, not to this level, but still have some, and you have the performance level. Why am I telling you this? If I have a floating floor, and I have the anchored version of the same floating floor, and it has the same amount of water on it, you're not going to notice it as much with this, because it's literally forcing it to stay to the substrate. So it's important to find out, if you can, from the owner, because if they have this, it's going to be in the last 20, 25 years. I mean, there are some that are out there that are anchored resilient, but not near as many that are out there. So if you ask the question, it's going to be newer information that should be on file. And it's important to note, because again, you're not going to see those effects immediately. So there's a lot of different variables to it. You're not necessarily going to be able to put down a magnet to decipher this. Sometimes you can get lucky and open the insert and see some steel or a pin. Or I was at a job in Reedsburg a couple weeks ago where one of the inserts showed a piloted pin placement hole, but it wasn't used. Well, that was just where it happened to line up to that insert. Then I knew it was a pin system. So it's nice to know that if you go